So in this lesson, we are going to look at how electricity is generated and then our consumption of electricity as well. And looking at, from an ethical point of view, some of the considerations we need to take into account in relation to generating electricity and consuming electricity as well. So the learning outcome that we are aiming at in this lesson is students should be able to research and discuss the ethical and sustainability issues that arise from our generation and consumption of electricity. So that's kind of like that's what we're focusing on in this lesson. So the first kind of concept we want to look at is just at a fundamental level, how is electricity actually generated? So if we think about, we turn on a switch here in our house and we have access to electricity. So we've been looking at in previous lessons what exactly electricity is. It's the flow of electrons through a conducting material like this. Okay, so it's the flow of electrons. But what we want to kind of think about now is how is that flow or how is that electricity actually generated? And in order to kind of understand that, we need to introduce magnets and we need to look at the structure of conducting materials like copper. So if we have a look at, so this is copper here, and in the middle we have the nucleus, okay, and in the nucleus you have protons and neutrons. Now in relation to electricity, it's all about the electrons. So you can think about these as tiny negatively charged particles that orbit around the nucleus of, for example, copper. And we know that copper is a good conducting material, but why is it a good conducting material? The reason is because of the way the electrons are arranged. So as we can see, if we look, each electron, the electrons are arranged in what are called orbitals. Okay, so they're just spaces outside the nucleus of the atom where the electrons hang out. And we can see that at the very last orbital in copper, it only has one electron. So we can see this one electron here and there's no other electrons. So this electron here, this one electron is kind of loose. And that means that that electron can easily be moved along. Okay, so it can be pulled away from copper. And that's what makes copper a really good conducting material. So electricity is the flow of electrons through copper. So what can happen is if we take a magnet, for example, so a magnet generates this magnetic field. Okay, so you have a north pole and a south pole, and then you get these. You think about them like a field that's generated around the magnet. And what can happen is if you take this magnet and you put it close to a piece of copper, what will happen is it will actually move this one electron that's on the outside of the copper. So you can think about this kind of electron is kind of loose, and when you take your copper magnet and you push it across a piece of copper, what it'll actually do is it'll move this one electron along. And that movement of the magnet across the copper gets the electron to actually move. And the movement of electron is the flow of electricity. So this is how we can actually start to get substances that have loose electrons in them to give up their electrons and get the electrons to move along. So just to kind of think about, if we had, for example, so imagine this is our piece of copper. So we have a piece of copper wire. Okay, so it looks something like that. And imagine inside this, so copper is made up of millions and millions of atoms of copper. And then each one of these little red dots here represents the loose electron that's inside the copper. Okay, so this electron here that's on the outside of each of the copper atoms. And then I take so this is a piece of copper. Okay, and then I take my magnet. So imagine this is my magnet here. And it'll have its north and south end. And what it's going to do is it's going to generate these magnetic fields. Okay, like so. And these magnetic fields are going to interact with the piece of copper. So if I move this back and forth like this, what's going to happen is the electrons inside here, these loose electrons that are on the copper, they're actually going to start to move. Okay, so it's going to apply a force to the electrons and it's going to get the electrons to move. And that's the basis of generating electricity. So if we can get copper and we can get a magnet and we can put them into contact with each other, we can get electrons to start moving. Okay, and we'll demonstrate this in class as well. But this is basically how it works. Okay, so you have your magnetic field here. And it makes sense. So think about it, if this is the electron here, so we have to apply a force. So we're applying a force, and that force is pushing, it's going to push the electron along. Okay, so that magnetic force is going to push it along. Also as well, if you have a positive charge, for example, from the voltage of a battery, that's also going to help the electron to move along as well. But these magnetic fields, they cause the electricity to, or the electrons to move through the conducting material like this. So if we take this fundamental principle and we scale it up, okay, to industrial scale in, for example, like in an electricity generating plant or an ESB plant. So we have something like this. So this is a dynamo. And if we have a look at the setup of this, okay, so let's think about how it works. So you have this coiled wire cylinder. So you have a massive cylinder, okay, and around that you have loads of like copper wire that's rolled around this cylinder. Okay, so like it's a huge cylinder. And then outside that, then you have these magnets, okay, like so. And what happens then is, so as we know, if we move a magnet back and forth across a piece of copper, it gets the electricity flowing in the piece of copper. But what we can do then is if we take this coil of copper that's coiled around the barrel, and then outside that we surround that with magnets, and then we attach that onto like a wheel. So when this wheel turns around, okay, what's going to happen is the copper is going to turn around, and it's going to turn around inside a magnetic field. Okay, so the copper is going to be moving around at high speed, and it's moving around inside this, inside like a magnetic field. And we know that what's going to happen is the magnetic force is going to apply force to the loose electrons that are inside the copper atoms, and it's going to cause the electrons to move. So they're going to be pushed along. And what will happen is this will generate electricity. Okay, so then this electricity generating piece will be attached up to, oh, sorry about that. So this electricity generating piece will be attached up to conducting wires, and that will take off this electrons. Okay, and the electrons will be moved along and fed into the grid. Okay, so this here will go to the electrical grid. So we have to think about then, so we have this component here, the magnetic piece and the copper, for example, and it works using this principle to generate electricity. But then what we need to do is we need to get this copper cylinder moving at high speeds, okay, so revolving around. And what we do is we attach this up. So this is what this piece here does. So we attach this up to a turbine and we get it to move around. So what are some of the ways that we can get this turbine to move? So again, in order to get it to move, we need to apply force to it. And how do we apply that force? Well, that force can come from steam. So imagine, so we're focusing on this piece here. So imagine it's like, if I even simplify it even more, so imagine it's like a propeller, kind of like this. Okay, and in here, and then what you have is then this is connected to this domino here. Okay, and basically what we want to do is when this turns around, it's going to turn the barrel of copper inside here, inside the magnetic field, and then it's going to generate electricity. So in order to get this to move, we have to apply some kind of a force to it. So what we can do is, if we take water, for example, so imagine this is like a body of water, okay, and it's in its liquid form, and if we apply heat to that, okay, so we heat it up, what's going to happen is that water is going to turn in, it's going to go from water and it's going to turn into steam. So it's going to change phase. So it's going to change it into steam. And you can think about, so imagine this is the steam here. So these are the water particles that are in steam form. And because they have a lot of energy, okay, so these are water or steam. Because these have lots of energy, what they're going to do is they're going to hit against the propeller. So they're going to transfer the kinetic energy that they have, energy because they're moving. They're going to hit the fan, okay, and that's going to cause the fan to rotate. So it's going to take this kinetic energy that has been transferred from the heat into the water, and it's going to get the fan to turn, and it's going to cause circular motion in the fan. And then as a result of that, that circular motion will cause this section in here to rotate, and then you're going to get the kinetic energy or the movement energy turned into electrical energy, because you're going to have the magnet inside here moving across back and forth across the copper, and it's going to get the electricity moving. So what you have is you have water being turned into steam from heat. That steam then is hitting the propeller inside here. That's causing it to rotate. That rotation then is causing this to happen up here. It's causing the electrons to move. So you constantly have this conservation of energy. So energy changing from one form into another. Now, this is the basis of how electricity is generated. But the problem lies in this piece here. How do we generate the heat? So what are the different ways that we can generate the heat to boil the water? Okay, so the most the most common thing that we're doing now is we are burning fossil fuels. So things like coal and turf. So we're actually burning these and we're creating like a little fire. And then that fire is producing the heat that's used to heat up the water. And this is a problem. And that's what we're going to start to look at now. But this is basically how like electricity is generated. It's generated through this process. So what are some of the ways that we generate electricity, and what are some of the ways, for example, that we heat up the water in order to turn the turbine? So that's what we're going to kind of focus on. So electricity is generated from some of the following sources. So we have fossil fuels. So fossil fuels are things like turf and coal and oil and other like they're the main kind of fossil fuels that we use, and like things like methane gas. So again, we literally burn this to heat up the water. We have nuclear fuels. So basically nuclear fuels, they use the process of combining or breaking up the nucleuses of certain atoms, and that releases huge amounts of heat energy, and then that heat energy is used to heat up the water to turn the turbine. So that's nuclear fuels. We can use wind. So again, we can have something like this set up. So instead of using steam to turn the turbine, we can use air particles to hit against the turbine and turn it. Okay, so that's the basis of wind turbines. We can use moving water. So again, instead of like heating up steam, what we can do is we can use things like dams, for example, to force water across this turbine and get it to turn, and again to generate electricity. Geothermal energy. So basically geothermal energy is if we take the earth, for example. So imagine this is the earth. So on top there's a thin crust. Okay, it's where all the plates are. But then in the middle there's a massive heat source. Okay, so you have like molten lava. So if you can put a pipe down into like deep down into the ground, what will happen is this heat, and then put water through it. This heat from the earth will heat up the water, and it'll make the steam that can be used then to turn the turbine. We have solar cells. So again, you're using, so if we have this water, we want to heat it up. So you're basically using, so imagine this is the sun. So you're using the heat energy from the sun to heat up the water. You can use that, for example, to heat up the water, or you can use it to generate electricity then as well. And then energy from fossil fuels. So the main fossil fuels that we use, so for example, the main fossil fuels that we burn, for example, to generate our electricity, we use coal, we use oil, and we use natural gases. Okay, so these are the main kind of fossil fuels that we use. And they're fossil fuels because they release heat energy when they're burned. So if you burn coal, it burns and it releases this heat energy, and then that heat energy can be used to boil water, turn it into steam, and turn a turbine. But the problem is these fossil fuels like coal and oil and natural gas, it's taken millions of years for these to be generated in the earth, and that process takes a long time. And as a result of that, these fossil fuels are limited and they're going to run out eventually. So let's look at this process that I've kind of outlined. So how is electricity generated? So the fossil fuels generate electricity by changing energy from one form into another, like this. So remember this conservation of energy. Energy is not created or destroyed, it's just changed from one form into another. So we have coal, oil, and gas are stores of chemical energy. So for example, inside the chemistry of coal and oil and gas, there's loads of energy. And when you burn it, you release that energy. So when burned, they release heat energy. So when you burn these guys, you start a fire with them, you burn them, what they do is they release loads of heat energy. The heat energy boils water to make steam. So for example, we take the water, we apply the heat energy to it, it boils and it starts to turn into steam. The moving steam has kinetic energy. So if we take this moving steam, it has kinetic energy, which turns the blades of a turbine generator. Okay, so it turns the blades of a turbine generator like so. The turbine spins the magnet near the coil of the wire to generate in the generator, which makes the electrical energy. So inside here we have a whole big barrel of copper wire, and then you have a magnet, and this makes the spin, and it causes this movement. It causes the copper to be moved inside a magnetic field, and that puts force on the loose electrons and causes them to move, which generates electricity. So this is the process. These are the steps that outline, let's say, how electricity is generated. So you get this process that's happening. Now the problem is that when we burn things like fossil fuels, we create these what are called greenhouse gases like CO2. So that's produced and sent off into the atmosphere. And that's a problem because it causes global warming. So some of the things to note about these fossil fuels. So at present, most of the world's electrical energy is generated using fossil fuels. So we're very reliant on fossil fuels to make our electricity. Their supply is limited and they will eventually run out. So again, this way of generating electricity is not sustainable into the future. It's okay for the time being, but future generations need to be able to generate electricity. Fossil fuels release carbon dioxide when they burn, which adds to the greenhouse effect and increases global warming. Okay, so that's a major problem. So for example, imagine, so this is the Earth. So imagine let me just do this here. So this is the Earth here. Okay, and we have a factory that's generating CO2, for example. And what happens is this goes up into the atmosphere and it creates a layer around. So imagine you have a layer around the Earth like this. So this is the Earth. And what happens then is you have the sun, and the sun is generating like light from the sun is hitting the Earth all the time. Now what happens is some of that light is reflected back off into space. But when you have a wrapping of carbon dioxide gas, for example, around the Earth, what it does is it stops this cooling down process. So as a result, it's like putting a really warm, like putting a jacket around the Earth. It starts to heat up, and as a result of that, when it heats up, it starts to melt the ice caps. So you have ice caps up in the North and South Pole. So that will increase the water levels and reduce land mass. And then also as well, you have like extremes in weather as well. So you might have really dry conditions. So you see like in California and places like in Greece, for example, they have a major problem with areas getting really dry. And then what happens is they catch fire and it just causes a massive fire. So these are all, these can be linked back to the burning of fossil fuels and the generation of this like greenhouse effect, the earth heating up and it not being able to cool down. Coal and oil releases sulfur dioxide gas when they burn, which causes breathing problems for living creatures and contributes to acid rain. So again, the burning of these fuels, it puts stuff into the atmosphere that it puts this sulfur dioxide gas, which causes breathing problems for living creatures, and it forms a chemical reaction that when it starts to rain, that rain it generates what's called acid rain, and that can have a massive impact on like wildlife. It can corrode like corals and things like that. So we've talked about this process. So again, this is like the general kind of mechanism that we use to generate electricity, and the problem is this process here, trying to get this turbine to turn, and the ways that we do that. And we generally use non-sustainable ways to like burning fossil fuels to get this turbine to turn. Okay, so that's the first part. So what's really important in this is that you understand how electricity is formed, and then that you understand the steps, for example, that we go through at the moment in order to generate electricity, and then like what are some of the problems with that. In the next portion, we will look at how power is generated by the generation of electricity, and then how to calculate power usage, for example. So again, we can see that it's very like it's every piece of electricity that we generate, for example, we need to be able to use the energy from that as efficiently as possible. So if we waste electricity, like leaving lights on all day, or just things like that in the house, if we're not very efficient with our electricity use, what happens is it's just going to make it more difficult for future generations. So for example, in the future, there's still going to be the need for electricity, but we might not have the fossil fuels to use this process. So that's why it's really important that we start to look at other ways to generate electricity. Okay, so that was the first piece that we looked at, how to generate electricity, and we will look at some more of this in the next lessons.